Hey folks, welcome to the first episode of EEs Talk Tech. Today we're going to be talking about USB Type-C and how it will inevitably take over your life.
And our guest today is Jit Lim. Jit Lim has been enabling customers for over 30 years in the test and measurement industry since graduating from MIT in 1986. I didn't know that about you, Jit. He's published numerous technical papers and helped many worldwide customers characterize and validate their leading-edge designs. Mr. Lim leads Keysight's Type-C, USB, and Thunderbolt technology solutions. We are really excited to have him here today. My name is Daniel Bogdanoff. I am co-hosting with
Mike Hoffman.
And we're both scope guys here at Keysight Technologies. And before jumping into talking about Type-C, I wanted to talk a little bit about why we have this podcast in the first place. One of the things that Mike and I love about working for Keysight is that we get to have hallway discussions with people who are industry experts and industry leaders in pretty much every electrical engineering application out there. People are, on the road talking to customers, talking about their measurement challenges. And we get to hear a lot of really cool information about what this means, what the upcoming technology means for the world at large. So USB Type-C is definitely one of the first things that I thought of when we thought about this podcast. It's something that, we learned about a couple years back, well before it was being integrated into devices. So today we're going to talk with Jit about Type-C and what that means for the world today. So Jit, thank you for being here.
Of course, I'm very clear. I started when I was 2, so I'm only 32 years old.
Sounds,
in case Emily was wondering
good.
about my age.
All right. So the first thing, why don't you just introduce what is Type-C? We've started to see it a little bit, but why don't you give us a little overview of Type-C as a whole?
I think you want to look at Type-C as one of the many competitors in the market. And I think one perspective is, decades ago when you guys were, before you were born, there was this thing called USB and FireWire, and they kind of, bash each other up for a while. And then there was kind of like a, DDR and Rambus, and they beat each other up for a while. And the question people always ask me is, Jit, who's going to win? Should I, go for, beta or a VHS? Exactly. Should I bet on, a FireWire or USB? One thing was clear. If I had known the answer, I wouldn't be here today. But this one thing I know is Type-C will win them all. That's the one that's really unique, is that the Type-C connector will take over all the other connectors. So that's one of the things that I know for sure. That's what you can bet on.
Okay.
It's that important.
Yeah, it really almost sounds too good to be true. When I first heard about Type-C and all the different, display technologies, power technologies, the data rates that you could transfer, the form factor of it. So one of the really cool things that I love about USB Type-C is it's reversible. So, the online running joke on the internet was that USB was the only fourth dimensional plug out there because you try to plug it in one way and then it didn't go in, so you turn it around, it still didn't go in, you turned it back the other way and it finally went in. So something changed from the first time to the second time that made it happen. That's going away with Type-C. And if I remember correctly, it actually has the same connector on both ends of the cable. Is that correct?
Matter of fact, let me show what I bring with me every day.
We have some show and tell here. Awesome.
Yeah, so I have in my bag these bits and pieces. So the first thing I'm going to bring out is something that connects to my drive. So I've got a storage drive because I use it to store all the waveforms we capture.
It's like an external hard drive.
Yeah, so it's got this A on one side, and it's got this, I think it's called a Super Speed Micro B. And I'll let you plug this one in.
Okay, and for those of you who are listening to the podcast, essentially it's this kind of long, flat, about the width of a USB plug, maybe a little wider, kind of flat. If you have an external hard drive, you know what this looks like.
As we can tell,
Super Speed
not
B.
so easy to stick it into that slot, is it?
No,
it's
not
Got to be very precise, and it doesn't quite. And then I've got this, I travel a lot, and I've got this noise-canceling headset, so I bring another one. I think this is A to a...
micro.
Yeah.
A to micro.
Just a
Is it a
micro B.
Yeah.
Okay. Yeah, a little micro.
And then I've got this other one here for the phone. But let me show you my little toolkit here.
You know, the most frustrating part for me is I have some peripherals that charge with a micro and some that charge with a mini. And I carry both around with me because I always forget which is which.
Yeah, I got myself little adapters.
So, as you mentioned, number one, you can flip the connector around, big deal.
Yep.
Yeah.
But notice, Type C, and there's no mini C, micro C, super C, micro C. It's C to C. So not only does it flip this way, you can swap the cables too.
So
that's really huge. There's only one Type C cable.
So just like HDMI or DisplayPort, it doesn't matter which end of the cable you grab, it's just going to plug in. When I compare it to a micro USB, the Type C connector looks a little bit bigger, but if you can see that, I'm sure you can't on the video. It's maybe only a couple millimeters wider than micro and maybe a millimeter taller. So basically like we have a micro USB cable on both sides. It's pretty nifty.
Now, it's funny you mentioned that as like a talking point, how it's the same on both sides, because it seems kind of like, well, of course, but over the course of the years, Type A was the connector to rule them all until the miniaturization of devices. And this just became unnecessarily unusably large. And so pretty much, I'd say 90% of the USB cables people deal with on a daily basis are different on both ends because it's host to device.
Actually, prior to Type C, 100% of the USB cables have to be different on both ends.
Really?
That's how you will never see.
There's no A to A?
An A to A cable. Think about it, right? When you plug this into your printer, it's that square B.
So annoying.
Right. With your phone. So you will never see an A to A, and there's some architectural reasons why that is so. Because there was a notion of what I call host and device and a source and a sink. And that's how you could tell by the type of connector.
Okay, so the type of connector dictated how the device behaved over
exactly
USB.
Correct.
Interesting.
So 100% did not. It was an illegal mode to have an A to A.
Interesting.
So transition point then, since Type C has no differentiation between host and device physically on the cable, what has happened is in the USB standard? Is there still that host and device relationship?
Yeah, the magic of all these capabilities lies in a new spec called a USB PD, USB Power Delivery spec.
Okay.
That's the spec that allows the product to be able to be a host to our device, to be a source of sync, to go into modes like alt mode, which I want to talk about later.
Okay.
And it provides all these new cool capabilities that did not exist before. So in conjunction with a Type C spec, there's also a new spec called a USB Power Delivery spec.
And is that a sub-spec? It's like an appendix to the spec? Or?
Yeah, you could call that, the customer can choose to implement them separately, which adds more confusion, which is you can have Type C without PD, or you could do PD without Type C, or you can do both, which is where the real power is, which is Type C plus power delivery.
So you could run power delivery as its own thing and not even implement like data transfer for Type C.
That's correct. You can actually choose to implement power delivery on standard A. I haven't seen too many versions of that.
Okay.
And it's actually been deprecated, which is the fancy word for in future versions, you cannot do that anymore.
Okay.
So is that kind of like the new MacBook, for example, charges over USB Type-C? Is that kind of the example of that cable is being used for power delivery only, since it doesn't really need to transfer data or information to the charging block, right?
It's a form of it, so it's a great question. So I have with me another little toy. I always bring this around, actually.
I'm just pulling out a charger of some sort.
If you look at it, at a charger, it looks like a regular Type-C charger.
Yeah.
But in the tiny words, which my old eyes cannot read, you will see numbers like 5 volts, 9 volts, 12 volts, 20 volts. So this thing that looks like a simple Type-C charger is actually got a power delivery silicon in there. And it can actually charge up to 60 watts, which is a big number. So you just don't plug this into anything. So that's where we get into some of the challenges and issues we've seen with Type-C chargers. Because this Type-C looking thing is no longer your, let's see, a 5 volt 900 milliamp. This is now 20 volts at 3 amps, 60 watt. And it could be up to 100 watts.
So as a frame of reference, what are some common devices today that are charged, and what are their power requirements? Like the average smartphone today, how much power are they drawing on a charge?
The phones don't require much to charge, but the value behind the Type-C PD ecosystem is how quickly you can get there. So, for example, you've got a meeting to go to, and he's like, I need to charge this phone up. Charge is pretty good today. An hour, you can get to 100%. But what do you have, 5 minutes? Right. Well, 5 minutes will get you maybe 5%. But if you could charge this thing at 60 watt, you might be able to get up to, say, 80% in 5 minutes, which would be a huge, huge deal. Yeah. Right? So there comes the opportunity. And as we have known in the industry, the challenge, big wattages are coming through these Type-Cs.
So before we get into big wattages, because I can just imagine people's devices, melting in their hands and that type of thing if they're not doing it correctly. 5 volts has almost become kind of this industry standard for, like hobby level type projects. You can power almost anything off of a USB cable. So you have the little, USB rocket launchers and fans and that type of thing. If you're working on a project and you need to source some power from something, almost universally, you're going to try and choose 5 volts because then you can just plug it into any sort of USB charger. What does that world look like going forward when USB Type-C is taken over?
Yeah, so the beauty of this new capability, which is PD coupled with Type-C, is that you have the ability to go up to 100 watt. So there are many use cases like this. So this has to do with the ability for high wattage, high voltage to be transferred in either direction of the data. So let's look at some very great use cases. So you bring your phone home, for example, and you plug it into your over Type-C with alt mode into your big display. So what's happened is now you're streaming video from your phone to this display, and the display is charging the phone.
Oh.
For example, now I do presentations almost every day. So very soon in the future, I'll walk into rooms with my laptop, and I can have the projector charge my computer while I'm doing a presentation, streaming from the computer to the projector. Now, more extreme examples of this would be, I'll have my own projector at 100 watt. I can easily light up a next-gen LED projector. I show up, I pull out my little LED projector, and I'm all there. I can get it all done by myself.
Then a power cable.
Yeah, it's just a regular Type-C cable. Now, as you can tell, I'm Asian. I love noodles. When they introduce the first 100 watt Type-C powered noodle maker, I'll be the first customer. Hot noodles next to my laptop, you can't beat that.
Nice.
So one of the things that I was a big fan of when I 5 years back, if my charger died from my phone or something, I would just go buy a cheap cable off of eBay. So I'd spend $1 and get a nice little micro USB cable, and it worked fine, more or less. Is this something that people, you think, could still do, or is the cost of this going to be significant?
I think the challenge and the opportunity is not about getting the cable, but because there is so much capability in the products and in the cable, it's no longer just a wire in there, and the large wattages available, it becomes a big technical challenge to get it done right. I believe over time, with great innovation, prices will drop, but you may have read that there have been serious issues with bad cables destroying products. So that's one example of a bad implementation. And of course, as we all know, in the past few weeks, there's been a very unfortunate incident with, a very large company having to recall all their Type-C phones. Now, clearly, it's very complicated because if they knew what the root cause was, they would have fixed it. So clearly, there's something more complicated in this problem.
Yeah.
And again, with great opportunity comes very significant challenges to getting this thing right.
That makes sense. So you mentioned briefly it's not just a cable anymore, like a typical USB cable. Can you expound on that a little bit?
Yeah. So we have all these great functionality, flipping and swapping of cables, and something we haven't talked about is alt mode. So let's talk about this great thing called alt mode. The way to look at alt mode is that essentially it replaces all these little ports on your computer. So I've got this computer over here. So this port right here is display port, for example.
Okay.
With Type-C alt mode, the products today that will go Type-C to display port, Type-C to VGA, Type-C to HDMI. That one Type-C port will essentially replace, last one, Type-C to DVI. It will take care of all display technologies with Type-C. Clearly, the USB ports become Type-C. Today, you can go Type-C to Ethernet.
You can. I didn't know that.
Type-C and USB can replace the jack today.
The 3.5 millimeter headphone jack.
Yeah, and Mike, right? Because we do that. We don't think about it because today when we have the, when we have those conference calls with a headset, right? We already use USB headsets.
Right.
We're already doing that, but there are new generations that we're able to do faster.
Well, and obviously the power port.
What other ports there?
Counts.
USB port, VGA, that goes away. Great point. That port goes away too.
Power connection, yeah.
Power connection, because Type-C provides that. So essentially, it's just not a pipe dream. There are many products launched maybe 2 years ago that all they had was one or two Type-C ports. It has already replaced all of these connectors.
Right.
So my new laptop has a Type-C port, and I went to a large electronics store down the road here looking for basically a USB hub for my Type-C port, and they had no Type-C anything. And I know that as time goes on, this is going to be more and more adopted. And it almost seems and feels to me like manufacturers are trying to kind of force Type-C into their products instead of it being a demand from users. Do you agree with that, or do you think it's kind of both ways?
I think it's both ways. I think there are a lot of consumers who want to move to Type-C. I think there are a lot of vendors who are promoting it. And certainly, if you go to Amazon, there is a lot of product out there. But you're correct, though, today, you still, there's a lot of adapters going on, C to A, C to B adapters that allow to use Cs. But
are those legal?
Very quickly.
Yes. Legal from the spec standpoint?
Absolutely. So, they are very clearly defined adapters. A great question.
Okay, so what should someone watch out for if they have a Type-C thing?
Is there a certification kind of?
Yes. So I think the most important advice we give our customers would be that you want to ensure that the cable, the connected products are certified.
Okay.
So certified. In fact, I believe the USBIF, which is the organization that owns the spec, has required that companies like Amazon, for example, they require that the cables and products be certified before they're put for sale.
Amazon, to their credit too, has been doing a great job of that lately in all standards and getting rid of copycat or lower quality cables with high return rates and stuff like that. And with Type-C, it sounds like the capabilities are so high that, like you said, there's dangers if it's not being done correctly. Like this, wasn't there something that happened recently at the Implementers Forum where somebody was cruising around trying to test a Type-C device and melting stuff?
That's correct. Yeah, because of the complexity, because of the various voltages and high wattages involved, a bad implementation can destroy stuff that perhaps 5 volts and 900 milliamps could not in the past. So this is, again, big opportunities, lots of different variations. So the user experience, it's like my mom in Malaysia, typical example. She plug in any way she wants. She plugs in this to a video. She doesn't know if that is running video over DP or HDMI or USB, and she doesn't care.
Right.
But that flexibility from a consumer perspective requires that in the background that a lot of smart stuff happens. And that's where it's very challenging.
That's a great analogy, because you see that in pretty much every walk of life as far as technology goes. Think about the internet. 20 years ago, if you were on the internet, you were kind of some savvy computer guy, right? Learning how to navigate the web. And now it's like, it's so accessible and easy, and websites are so easy to interact with because of all the complex stuff happening in the background. It's all about making this extremely high-powered technology extremely accessible, so you don't have to be an expert to use it.
That's exactly correct. And getting it right, it's very challenging in this ecosystem.
So I'm going to go back to the alt modes and how Type-C handles all these different technologies. And I'm wondering how that's implemented inside of the spec, because obviously the connector is different. Is there hardware for each of those different specs in there? Is it all done, just they take the protocol layer from those specs?
Yeah, so actually the connectors are all the same, and they have to be. So the physical hardware cables and connectors have to be the same for the Type-C ecosystem. Again, the magic of alt mode is in the USB PD spec. There's a very special new line. It's called the CC configuration channel line. And over that line is where all the protocol happens. Basically, what happens over that line is when the connection is made is the host will say, hello, I can do these things. I can put 100 watt, I can do USB, I can do Thunderbolt. And then the device says, oh, I can do DisplayPort, and I want to have 60 watt. Then they decide on a contract, and that's what's negotiated and agreed upon.
Okay.
So that's the general process. But hardware is the same. The magic happens over the CC line.
And that's a dedicated pin in the cable and in the connection there?
That's a great point. So it's in cables, there should be only one CC line that connects from the host to the device. Early bad versions of cables had two.
Okay.
And that was a bad thing to do. So there's one of those pitfalls because the cables are reversible. You need to have only, in many cases, only one line that connects true. It is a one line. It's called CC1 and CC2, but in a cable, there's only one CC line. And depending on which way it's connected, CC1 or 2, that's when a product will output a signal on the CC1 or the CC2 side. And that's how you have this sense of a flipping.
Okay. And kind of a silly question here. The adapter is obviously reversible. If you have one, are the pins all identical on both sides, or is there some sort of sensing that takes place?
Yeah, it's completely symmetrical. And what you bring up is a very good point about how challenging it is. It's a symmetrical connector physically, but there's very specific pin outs and connections called out in the USBIF spec that says what these things are.
Okay.
And then when you go to alt mode, certain specific pins can be repurposed to output, say, USB or Thunderbolt or DisplayPort.
Okay.
That's
does that switching happen inside the cable? It must be on the device side.
Yeah, the switching doesn't. The cables are in a sense passive, if you will. They just pass signals through.
Okay.
But after the contract is negotiated, then the silicon or the products, the device or host, will then route the appropriate signal to these switches and muxes so that things will operate correctly.
Okay.
And that's where the challenge is.
So in previous iterations of USB, the host and device relationship was fairly obvious, but we're moving now into a realm where it's not as obvious. So during this negotiation, which device does the initiation? Do they both raise their hand and say, I'd like to be the host and or device? And then do they go from there? Because, for example, I've heard of the scenario of what if you're out and about and your phone's dying, you can plug into somebody else's phone and charge your phone with somebody else's phone. Right. As a potential opportunity, and those are both kind of devices. So how does that relationship
Great point. So earlier we talked about how you had an A host connector and a B device. In that scenario, the A part that plugged in was always the host, and it was always the source of power, period. Okay. You had a device that always took power only. Okay. There was a unique thing called OTG, but we'll not get into that today on the go. And to your point today, this product could be a host.
He's holding a phone for those of you on the radio.
it could be a host, and it could receive power. So the words here, it could be a host or device, similar to what is called before, or it could be a source and sink, but it can flip. It could be
Okay.
host syncing, or it could be device sourcing. So now the question is, how does it happen? Right? So what happens is that when you connect this product, whatever it is, to another product, it has a state it wants to be. So for example, if it needs charge, it will advertise something called the RPRD resistor network. That's one of the fundamentals of Type-C, is to put in these specific resistors. And their job is to tell the other product what it wants to be. For example, if you're a charger, it always advertises something called RP, which says, I will always be a source because I'm a charger. Or if you're a USB stick and it always requires power, you always advertise RD that says, hello,
Drain.
I always want to be,
And
syncing power. Exactly.
yeah. So is there like a hierarchy of these then? Or, it's a resistor network, so are set resistor values associated with different, device classes, for lack of a better word, or is it?
Yeah, so there are different ones. So depending on the values of these RPRD resistors, you will, for example, advertise that you want just USB default current. You want Type-C 1.5 amp current. You want to go Type-C 3 amp current. But if you ever want to go above 5 volts or 3 amps, then you need to add PD. So this is one of the unique features of Type-C, which is you can have Type-C without PD up to 5 volts and 3 amps. Or you can have Type-C with PD, which allows you to go up to 20 volts and 5 amps.
100 watts of power over USB is still, blowing my mind.
Does the cable get hot?
Well, it's funny you say that. So we actually have a fixture that Type-C fixture we designed. And so we didn't know if customers, what they would hook it up to. So we had to test it at a level. And let's just say, even though there are 8 pins, there are actually 4 V buses on that little connector and 4 grounds. When you pump 100 watt through that little connector, it gets pretty warm.
So what have we seen people implementing in already released products as far as power delivery goes? Is that in the future? Is that 1 year out, 5 years out, or have we already seen power delivery, being implemented today? And what does it look like?
Well, so this, this chart is a perfect example of how, we have gone from a basic, low wattage 5 volt 900 milliamp USB charger to a 60 watt charger. Okay. So folks are really embracing the notion that instead of, a basic low wattage charger, you can pump a lot of power and charge things much quicker. Everybody wants quicker, right? I mean, if someone said to you, hey, you can get your phone or your computer charged in an hour versus 5 minutes, most people go, yeah, I'll take the 5 minutes.
Yeah, absolutely.
What's your time worth?
Yeah, right. But again, we want to be cautious because once you have that much power going through, things get hot, and so there's always the need.
Are there temperature sensors implemented, or is that more up to the device?
Yeah, so generally products like these have to have different fail-safe features in their charging circuitry, for example. So if it gets above a certain temperature, then it needs to slow it down. So they are supposed to have these kind of a protection circuitry in their charging systems.
Okay. Awesome. Any other questions you have for Jit here?
Let's see here.
One of the things, and we maybe touched on it, the cables are actually active instead of passive, which
kind of. We were talking about this a little off camera. So
they can be, but they're certainly active cables for applications where the customer needs a longer tether, for example.
Okay.
But I think in general the audience is lower cost, so there's certainly a lot of passive Type-C cables out there.
Okay, that makes sense. So it's more of an application over a long distance.
That's exactly correct.
Okay.
There's certainly long applications out there.
That's something we see with HDMI now is you almost need active HDMI cables to get more than 10 or 20 feet reliably out of an HDMI cable.
So I'm holding up here the receptacle, the Type-C receptacle of this charger. Is there any silicon in this sleeve between the metal connection and the wire? And if so, what does it do?
It's a great point. So you have a PD silicon that does the negotiation, but all cables and connectors need to have a EMARC chip. And let me tell you why. So earlier mentioned the host and device sets up this link that says, hello, I'm going to put 100 watt out. And the device says, sure, give me 100 watt. But let's not forget there's something in the middle.
Yeah.
If that cable can only deal with, say, 15 watt, bad things happen. So as part of the PD magic.
Firewire for real.
That's a good one. I like that. That's good. I'm going to think about that connection. That's really good. So you can see how the host and device says, hey, let's go 100 watt. And the cable goes, no. Yeah. Right? So as part of this PD magic, not only does the host and device says, hello, I can do this. There are eMark chips that says, oh, I'm a 15 watt cable, which means I'm not going to take much more than that.
Oh, interesting.
So there's a very small, low-cost chip in all these Type-C cables that say,
don't shoot the messenger.
Exactly. Right. It doesn't advertise. It just says, this is what I can do. So it's lower cost. Okay. It doesn't negotiate. It just says, this is my capabilities.
Right.
And it's just, embedded in this chip here. So
great question. We are actually out of time. It has gone incredibly fast. One of the things we'd like to do with this podcast is come with predictions for what we think, something related to the technology that we're talking about. So why don't we go ahead and get into those? So we'll start with Jit. What's your prediction for the future here?
If you look at it from the power perspective, there's huge potential. Charging, various applications with high wattage. The other thing that that excites me is bandwidth, or how much capacity this Type-C can do. There are actually 4 very high-speed TX-RX pairs in this connector. And today, the way Thunderbolt is implemented, it runs 20 gig on all 4 lanes in parallel. So that port, when Thunderbolt is running today, is an 80 gig port. So the way USB implements it today, it's idling. It only puts 10 gig on one side. You can see where the future could be. Because that connector today will run 80 gig.
Interesting.
Is that what you're getting at?
It's just a speed. In other words,
could be for anything.
It could be anything. In other words, there is nothing that prevents future versions. And again, it's not been released, but nothing prevents future versions of USB to potentially run 20 gig on all 4 lanes. 80 gig USB in the future, because we know that the PHY layer, which is what this cable connector is, does run at 80 gig.
Has a ton of overhead, is what you're saying.
Thunderbolt does that. So this
interesting
technology has very long legs. I'd say it's a ton of overhead, but I think folks, right? We're always bandwidth hungry. If there is a fat pipe, we will figure out how to use it.
Well, and then bring on 5G, 6G data networks that kill, home internet as we know it, and there's your, consumption. So,
right.
Mike?
My prediction is we start seeing Type-C power delivery in things that aren't traditional consumer electronics. Think how to plug in and charge your Sonicare toothbrush or your toaster or what have you, home electronics outside of the consumer electronic space.
Great. And my prediction is if you thought phones blowing up was a problem, wait till we're delivering 100 watts to home automation systems. So that's all we have today for EEs Talk Tech.
I'm scared, man.
If you have any questions for us, you can put them on our YouTube channel, on our Facebook channel. Go check it out, Keysight Oscilloscopes. And if you want to learn more about USB Type-C testing, go to keysight.com and search for USB Type-C. Jit, it's been a pleasure having you. I'm Daniel Bogdanoff, my co-host Mike Hoffman. We will see you the 2nd and 4th Thursdays of every month. Thanks for listening and watching. We'll see you next time.